All right, welcome back for yet another application of lines, equations of lines. So now we're going to be getting into parallel and perpendicular lines. So a couple of key facts. If we have parallel lines, then the one major thing we should know is that their slopes are equal. So M1 should equal M2. But when two lines are perpendicular, that only occurs if their slopes are negative reciprocals of each other, or we can have M1 equal to negative 1 over M2. So we should be able to show one of those two conditions, or those conditions have to be met in order for those lines to be as indicated. So let's try a couple of applications. We got find the equation of line satisfying the given conditions, giving it in slope-intercept form. So we want our final answer in slope-intercept form. So it has to pass through negative 1, 4, and it has to be parallel to this line. So where do we begin? Well, we can't create a line unless we have two things. Minimally, we need to have a point and a slope. So we don't have a slope, so we're going to need to find the slope of the line that we're given. And what's the easiest way to do that is to put it in slope-intercept form. So if we move the x over to the other side, 3y equals a negative x plus 5. And then if we divide by 3, we'll get that. Negative 3, negative 1/3 x plus 5/3. So now we have our slope. M is equal to negative 1/3. So this is what we have. So what do we need? So that's the thing. We have what we have, we need what we need. So if they're going to be parallel though, we need them to be the same. So we need M equal to negative 1/3 as well. So now we have our two elements. Now we can get our line. Now remember, we have two ways to create those lines. We can use the point slope form or the y equals mx plus b method. So if we like the y equals mx plus b, I do. Let's go with that one. So 4 equals a negative 1/3 times negative 1 plus b. All right, so we gotta multiply, and then we gotta subtract 1/3. Now, most people don't like fractions, but if we change it to thirds, that'll make life a little easier for us. So we know that this is 12/3. So 12/3 minus 1/3 better be 11/3. So b is 11/3, and now we're good to go. So y equals negative 1/3 x plus 11/3. Now, again, most people don't like improper fractions. I personally don't care. They're fine in my book. So, but if you wanted to change that to a decimal, you could. If you wanted to change it to a mixed number, you could. But improper fractions are a little bit cleaner usually. So, but there's our answer. All right, let's try the next one. Through 1/6 perpendicular to 3x plus 5y equals 1. So, again, we need to work with what we got to see what we have. So if we move the 3x over to the other side, we'll get a negative 3x plus 1. And then let's divide by 5. So we'll get negative 3x, 3/5 x plus 1/5. So we have m equal to negative 3/5. Perpendicular would say we need m equal to what? It's not the same. Remember, we want that negative reciprocal, so we got to flip it and negate it. So m better be equal to 5/3 in this case. So now we can use our 2 bits of information. Let's just jump right into plugging them in. So 6 is our y, m is 5/3, x is 1, and then we have our b. And so now we can simplify this. Since this is going to be in thirds, might as well change the 16 into thirds, so that's going to be 18/3. And so now when we subtract the 5/3, looks like we're going to get, whoops, can't write my numbers too small. So it looks like 13/3. And so now y better equal 5/3 x plus 13/3. All right. So far, so good. All right, let's try one more, and then we'll take on the last question in this section in the next video. Excuse me. So through -2, 4, and we want it parallel and perpendicular to y plus 5 equals 0. That's weird. So they want 2 equations parallel and perpendicular to this. Well, let's do what we've been doing. What do we got for a slope? So if we solve this for y equals a -5. All right, well, what's that look like? All the y values have to be equal to -5. It doesn't matter what the x value is. So no matter where you are on the x value, always go down to -5. So that's going to give you a horizontal line. So if you have a horizontal line, your slope is equal to 0. So if we want a slope of 0, that would be parallel. So that's going to give you what for an equation? Well, let's plug everything in. Same way we did up here. We're going to plug all this information into our y equals mx plus b. So we got 4 equals 0 times -2 plus b. So we got b equals a -4. Or excuse me, b equals 4. And so now, let's plug it in. So y equals 0x plus 4. So y equals 4 is the equation of the line that's parallel to this line. What about perpendicular, though? What's that going to be equal to if it's perpendicular? So if we want something horizontal, it's going to have to be vertical. So a vertical line is perpendicular to a horizontal one. But what's the slope? Well, if you keep increasing the slope, maybe I should go the other way. If you keep increasing the slope, eventually it keeps getting more and more positive, until it's infinite. And infinite is the same as saying undefined. So it's an undefined slope. So how do we tackle that? Well, there's no real easy way to do this. So, but it has to pass through this point. X is -2 and y is 4. So if we were to draw that, it's going to be in the second quadrant somewhere. We want a vertical line. So the x value is always -2 on this line. No matter where we pick, the x value is -2. The y value is going to change, but the x value won't. So in this case, x equals -2. Kind of a weird one, I know. Anytime it's undefined, though, you can always assume that it's going to be x equals something. That's a gimme. So, undefined slope, x equals a number. Slope of 0 is always y equals a number. So that's your clues. All right, so let's pause here and we'll jump to the next video for the rest of this section. See you soon.